Ladies and gentlemen, so today we have one interesting question under matrices, which reads to say find the determinant of this guy. So for you to basically find the determinant of this guy, we use this operation: positive, negative, positive, negative, positive, negative, positive, negative, positive. So this is the operation we are going to use. So basically, we can even work with the first row there. So if you choose this row, you have basically chosen this. If you choose this column, you have basically chosen this column. Just like that. If you choose this row, you basically choose this row to work with. So let's work with this one. So basically, if you get this positive, meaning you have chosen one. So if you have chosen this one, what you basically do here, you hide this column where the one is, and you hide the row in which one is. Then what you will remain with is what you are going to work with. So this is what we basically do. Then you go to this negative, meaning you have chosen I, and you say hide the column and hide the row. So you have I, 1 plus I, 1 minus I, and 2. And you basically have the 0, which is positive 0 here. So you hide the row in which 0 is and the column in which 0 is, and you have I minus 1, 1 minus I, and 0 here. So this is what you basically have with your operation. We know that no matter how much we can find the determinant, so long as we are multiplying it with 0 at the end of the day, the whole lot of the matrix, which is a 2 by 2 in this case, is basically 0. So we will only work with these two matrices. So we know what we usually do here is to work with the same way you usually work with the determinant of a 2 by 2 now is the same way we work with this one. So positive 1, so this times that is basically negative 2, and we know for sure that this times that is 0, this times this is 0. So we can just leave it there to avoid ambiguity. So minus I, this times that is basically 2I. Then we know that this is just the same as a rationalization of complex numbers, where you can multiply 1 times 1. Remember, it is first a negative, so 1 times 1 is 1, and negative I times I is simply negative I squared. Yeah, I know maybe someone will ask, say, why have you gone that? Even if you want, you can say 1 plus I, 1 minus I, and you have 1 times 1 is 1, 1 times negative I is negative I, this times that is basically positive I, this times that is negative I squared. Remember, these here will basically give you will give you a 0. So it will be 1 minus I squared. So this is that function there. This is just rationalization. The way or why we knew very fast that this is rationalization is because here there is positive, here there is negative. So 1 times negative 2 is basically negative 2 minus I. So we have 2I here minus, we know for sure that I squared is simply negative 1. So we have 1 minus negative 1. So we have negative 2 minus I, which is 2I. Remember here, the answer negative times negative is positive, and 1 plus 1 is basically 2. So this is what we will end up with. Then again, we need to multiply I times what is inside, and you have negative 2 minus 2I squared. This times that is basically positive 2I. So we will redefine what this is. So you have negative 2. Remember, we said this is negative 1 plus 2I. So we have negative 2 plus 2 plus 2I, where we know for sure that negative 2 plus 2 is basically 0, and you have your answer to be 2I. So this is how basically we solve or rather determine the value of the determinant for this particular matrix we were given above here. So this is how we work it out. Your host, Gordon Zulu.